All right, we got a trouble ticket here, and it's regarding BGP, right? What fun. So this is CCNP Seth, and I created this topology, and I thought it was fun to create this trouble ticket. So what do we need to do here? So let's see what step one is. R6 and R8 needs to take the optimal path to networks 100.100.100/24 via R4. All right. And then 50.50.50.0/24 via R3. All right. So that is what our goal is. And here are our steps. Take actions such as edge routers have higher local preferences to their closest BGP neighbors, and it propagates through Autonomous System 300. And then finally, create a route map for network 100.100.100.0/24 to go out R4, and then that 50 network to go out R3. So what this is saying is we need to have a local preference propagate through our autonomous system here to prefer this route. So we're going to have to change the local preference. So by default, that's 100. And then R3 is going to have a higher local preference for this network to propagate throughout our network right here. So, all right. So let's get into our routers. So let's go into R6. And let's do a show IP route to make sure that it doesn't see it. And we should hear about it via BGP, and I do not see any 100 networks or even a 50 network. All right, so then let's do show IP BGP. And we don't have anything. All right, so what's the first thing we do? Let's see which BGP router knows about that network. So let's go into R7. Whoops, I already have it open. And do show IP route. He doesn't know about it. And does he even know about it via BGP? No, he does not. All right. So let's move on to R5. Show IP route. All right. It doesn't have it in its routing table, but does he know about it via BGP? All right, so he does know about it. Notice that this star here means it is a valid route, and it knows about it via two different ways, but it doesn't have this symbol right there for the best route. So why doesn't it have, why isn't this BGP route installed into the routing table? Well, if you look at the route attributes, you look at these next hop addresses right here. So to get to the 50 network, you have to go to the next hop of 14.14.14.1 and 35.35, blah, 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 blah. So does he actually know about those routes? Do a show IP route, and I don't see a 14 network or a 35 network at all. So that is a BGP rule or IBGP rule where if it learns about a route from the outside, this router right here, this edge router, will not change its next hop address to an IBGP peer. So, okay, we have to look at that. Also, why didn't R7 learn about these routes if R5 did? Now, this has to come into play with this IBGP rule called split horizon. And in that, since R5 was a first hop peer of R4, he received those routes, but the rule for split horizon for IBGP is do not advertise a route to another IBGP peer if I learned about that route via IBGP. So he learned it from R4, who is an IBGP neighbor, and he will not advertise that out to R7. Okay, so what are our options? Well, what we can do is we can create a full mesh to all of our routers to propagate that, so R6 will know about it. So we'd have to create a neighbor statement for R4 to R6. And if we look at our rules here, it says no extra neighborship should be established, so we can't add any more neighbor statements. So what can we do? Or actually, I'm sorry, neighborships. So what we can do is actually implement route reflectors. So what a route reflector does is it gets rid of this split horizon rule to where I could pass that to any iBGP peer I want to, as long as I deem them a route or I deem myself as a route reflector, and then I push that to my clients. So one thing about route reflectors is that it needs a full mesh to work. So for R8 to get a route sent from R5, well, he has to push it to R7, and then R7 has to push it to me. So these two routers, R5 and R7, they will be route reflectors. All right, so let's go ahead and configure that. So let's go into R5 and configure those neighbor statements. So router BGP 300, router BGP 300, and do those neighbor statements. So it's neighbor and who is going to be an iBGP peer. Basically, it is going to be R4, R3, and R7. So we need to create 3 neighbor statements. So to get to R7, it's going to be 57.7, and you will be a route reflector client. And we just rinse and repeat. Let's see here. What is it? 45.4 will be one, and 3, R3. So what is that? 35.3. And notice once I do that, the BGP will bounce up and down once I create that. All right, so that looks good. And let's do the same thing for R7. So he's going to be a route reflector, so he needs to have that route reflector statement to 3 neighbors, R5, R6, and R8. So let's go into R7. Config T, router, BGP 300, neighbor, 10 dot, where is he going? To 6. 0.67.6 route reflector client. Same thing with 8. 78, and then back to router 5. So what is that? 57.5. All right, so that's that. Let's end it, and let's actually see if R7 has that route now. IP BGP. Not yet. He should get it now. Remember, BGP is slow. So we'll see how that works. Let's give it one more time. All right. Well, let's continue. I'll wait for BGP to do its thing. So, all right. What is next? So now we need to move on to this step. Take actions such as edge routers have a high local preference to their closest BGP neighbors, and it propagates through the autonomous system. So we need to make sure that R4 propagates a higher local preference for this route. So what do? I'm thinking let's create an access list and apply it to a route map and then apply it to our neighbors. So let's get into R4, config T, and an access list. So let's say access list 99, permit, and then what is that network that we're trying to permit? 100 with a /24. That's it. And now let's create a route map. Route map. Let's call it local preference or local pref, and it will be what? Permit sequence 10, and let's match it with that access list we just did, address 99, and let's set the local preference of 200. Bam. And now let's apply that to our neighbor. So router BGP 300. R5, so our neighbor is 10.0.45.5. What? Route map local underscore preference. And let's push it outbound. All right, so let's do the same thing on R5. I'm sorry, what is it? R3? R3, so it pushes out this 50.50.50 network. All right, so let's go ahead and do that. All right, so let's bring up R3 and let's do that same thing. Config T. What do we do first? Create the access list. Access list 99, permit 50.50.50.0 with a /24 or a wildcard mask of. That looks good. And the route map. Route map. Let's call it the same thing. Preference permit 10. Match address. IP address 99. And let's set the local preference. Let's do this one 199. Oh, you know what I forgot on the other one? We got to do another permit statement to allow all other routes. So let's do the up arrow and let's do permit 20 and let that be. So let's go back to R4 and let's do that. Are we still in exit route map? What is it? Local underscore preference. Pref permit 20. So all other routes will be permitted, but we want to set a specific preference on one route. All right. Oof. Is that it? Oh, I forgot to apply it on router 3. So let's apply that route map to router 3 to its outgoing neighbor. Router BGP 300. The neighbor statement. 10.0.35.5. Route map local underscore preference. And let's put it outbound. End. Good. Good. So now let's bump. Oh my gosh. Let's clear the BGP process here. Clear IP BGP star. So we should lose our neighbor relationships. Come back up. All right. So let's go back to R7 to see if it finally got those routes here. IP BGP. No! Why isn't it working? Let's see if R5 is getting it. And show IP BGP. Okay. Notice that we got a change of a local preference, so that means the route map worked. But, of course, BGP is slow, so there we go. We finally got 50 here. All right. So let's see if R7 got it. Did we not do show? We should have got that route. Let's look at show run section router BGP. Route reflector client. All right, 5.7. Yeah, it should work. Should have all got that route. Router 7 should have got that route. So let's clear IP BGP. And let's do that for all of our routers here. Clear IP BGP star. And hit the up arrow. No! Why isn't it working? Ah, why isn't it working? Because we need to do the next hop self. If the next hop self isn't valid, it's not going to pass on that route to R7. So what we have to do is let's change the next hop of that route, because if we go into router 5, show IP BGP, the next hop is still invalid. That's why it's not in the routing table. So let's change that on R4 and R3. So go into R4, config T, router BGP 300, and let's do our neighbor statements. Neighbor 10.0.45.5. Next hop, self. Hit enter, and let's go into router 3 and do the same thing. Config T, router BGP 300, neighbor 10.0.35.5, next hop self, end. And for good measure, let's clear the BGP process. make sure everything is good. Clear IP BGP star. Now, let's see if it worked. Come on, BGP. No. Did the next hop self change with router 5? Still waiting for this process. So let's wait for BGP to do its thing and we'll come back. All right, so I didn't do anything. I just kept hitting the up arrow and we finally got those routes. Notice the local preference changed to 199 and 200 and the next hop changed as well. Good. So let's see if R7 got it. And it got it. So now let's look at, what was our original one? Router 6. Shell IP BGP. Good, and it learned about it, and it should be in the routing table as well. Shell IP route. Bam, look at that. So now we could actually ping it. Ping 100.100.1, and let's source it from our loopback. Bam, look at that. And if we do a trace route, loopback 1, and it took that path. Let's see here. So 14.14.14.1 is this interface right there. Well, actually that interface. So that worked. And actually, if we do 50, we should get another. It should go through R3. And it did. It went through 35. Good. So that was it. Yep. So this was a fun trouble ticket. It took a little bit longer than I wanted it to, but this is BGP. BGP is slow, so you can't get instant results. So I hope you enjoyed this trouble ticket. I'll probably create a little. I'll probably create more. It won't be this complex, but I just thought that this was a fun topology. So I hope this was informative for you, and then I'd like to thank you for viewing.